So, are you tired of boring old Earth? Want to know what lies beyond the starry night sky? You're not the only one. People have been asking the same question for centuries. Luckily, scientists have got you covered. They've discovered a lot of amazing places light years away from our blue planet. Just one light year is about 6 trillion miles. Mind-blowing, huh? So, hop on. The spaceship of knowledge is lifting off. Your first stop is 2.5 billion light-years away from Earth. It's a quasar, one of the brightest objects in the universe and the first one to be discovered. A quasar isn't a star, but a distant galaxy. This extremely bright object gets its power from a supermassive black hole. A disk of matter swirls around the black hole and creates friction. It's kind of like when you're cold and rub your hands together to stay warm. The friction between the palms creates heat, making you feel nice and cozy. The same happens in the quasar, just the amount of heat is bigger, way bigger. I hope you remember to pack sunscreen lotion. The temperature at the heart of this quasar can reach 18 trillion degrees Fahrenheit. Also, there is light, a lot of it. This celestial object shines 100 times brighter than all the stars in its galaxy put together. Well, it's time to cool down a bit. Minus 457 degrees Fahrenheit, to be precise. This is the temperature of a young planetary nebula called the Boomerang Nebula. It sits 5,000 light-years away from Earth. NASA's Hubble telescope caught images of the formation in 1998. It's composed of gas coming from a star near the end of its life cycle. Inside the nebula, it's windier than in the Windy City. Winds reach speeds up to 310,000 miles per hour. And you gotta thank them for the nebula's chilling temperatures. Researchers were just impressed to find out that the temperature of the Boomerang Nebula is just 1 degree above absolute zero. 0 Kelvin should be the coldest temperature possible. This is the point where all molecular and atomic activity stops. Brr! Makes you want to crank up the thermostat in your spaceship. Next, you're going to a place you might not want to visit. Sorry. So, it's the most massive black hole. This giant is located at the heart of a large galaxy, some 10.4 billion light-years from our planet. Its mass is 66 billion times greater than that of the Sun, enough to make our galaxy's supermassive black hole feel ashamed. It has a mass of merely 4.5 million times that of the Sun. But you better not get near any of them, as a black hole's diet consists of matter. By calculating how much matter they consume, scientists can determine their rate of expansion. And those black holes have quite an appetite. Astronomers believe there are stupendously large black holes, or slabs, hiding somewhere in the universe. If they're real, their mass is estimated to be greater than 100 billion times that of the Sun. Now, it's time to snack on something lighter. The spaceship enters the Kepler-51 system. It's home to the lightest planets in the known universe, called superpuffs. Sounds fluffy enough, and it is. These planets' mass is either the same or slightly greater than that of Earth. But this doesn't mean they're small. Think of them as giant cotton candies the size of Jupiter. They are newly born planets whose atmosphere is still cooling down. You might want to wait for this process to be over, though, as 500 degrees Fahrenheit is too hot to handle. But for experts, superpuffs are special. These planets are incredibly rare, as they've managed to discover less than 20 so far. Now, are you up for a race? Let's say the ship you're on is traveling at a speed of 25,000 miles per hour. This is the current human speed record. It was set by NASA's astronaut trio from the Apollo 10 mission in 1969. And no, I am not talking about Neil Armstrong and Buzz Aldrin. That was the Apollo 11 mission later that year. Right now, you're going to race against a star 18,000 light-years from Earth. Your biggest advantage is that this is a neutron star. It was formed when another massive star ran out of nuclear fuel and couldn't support itself anymore. Think of a car running on an empty tank. Victory couldn't be any closer, right? Well, not quite. When a massive star feels like its time is up, it shrinks and starts spinning. Figure skaters do the same during a spin. They fold in their arms to increase rotation to the maximum. This neutron star is the champion of the universe. It spins at a speed of 157 million miles per hour. That's roughly 27% of the speed of light. Whoa! Are you running low on energy at this point? Time to charge up from a gamma ray burst. Gamma rays are electromagnetic waves generated by various forms of radiation. These bursts were fairly unknown to science until the late 1960s. Satellites equipped with gamma ray detectors accidentally recorded huge outbursts of radiation outside of our solar system. What were they? Nothing dark, definitely, as these are the most energetic forms of light. Scientists believe that gamma ray bursts happen when two neutron stars collide and form a black hole. The other explanation is that they are in the final stage in the life of a supernova. This event happens when a star decides to go out with a bang. Gamma ray bursts shine brighter than a diamond. They are 1,000,000 trillion times brighter than the sun. Talk about an energy boost. Your mood is lightened up by now. You want to visit a place that has a draw to it. No, it's not a beach resort, but a magnetar. It's a neutron star with a twist. Magnetars have a magnetic field that is 1,000,000,000,000 times stronger than that on our planet. But don't fall for their strong appeal. Let's just say you won't live to tell a tale if you get too close to one. In 2004, a flare that came off the surface of a magnetar managed to compress Earth's magnetic field from a distance of 50,000 light-years. Quite impressive for a star the size of a city. Makes you wish to team up with this oversized magnet to commit the greatest heist ever. A magnetar has the ability to swipe all the credit cards on planet Earth from a distance halfway to the moon. Luckily for humans, NASA has discovered only 31 of these stars so far. You have barely escaped the pull of a magnetar. Suddenly, you start to sense a strange force drawing you away from your home base. It is the Great Attractor, one of the biggest mysteries of the universe. This massive gravitational irregularity has been pulling us closer and closer to it for billions of years. Scientists estimate that the Great Attractor is located at the center of the Laniakea supercluster. The name means immeasurable heaven in Hawaiian. It represents a gigantic collection of planets, stars, and asteroids. Our home galaxy, the Milky Way, is just a speck in this enormous supercluster. According to the Big Bang Theory, not the TV show, the real theory, the universe has been expanding in all directions. But the mysterious Great Attractor is slowing things down. How exactly? Researchers still need to figure this one out. On the bright side, they are good at naming things. The end of the universe would be called the Big Crunch, if there's anyone left to call it that. Your journey, too, ends at the edge of the universe. The most distant galaxy from Earth is the oldest one as well. The galaxies that formed first after the Big Bang have drifted the furthest. So every time advanced telescopes detect a far, far away dot, they give scientists an image of the origins of the universe. Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans, its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but two at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the Sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? Alright, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
The infinite vasts of the universe hold endless possibilities and secrets. And here's one of the intriguing questions: how life and we as humans would look like on other planets. Imagine a world where the laws of physics, the environment, and the conditions are vastly different from what we're used to. How would we adapt and evolve to survive in these strange new lands? Let's see. Mercury is the closest planet to the Sun and has a thin atmosphere. The temperatures there are extreme, with the day side reaching over 800 degrees Fahrenheit and the night side dropping to negative 290 degrees Fahrenheit. So, what can we do to survive these crazy temperatures and constant solar radiation? Maybe we can magically turn into metal. For example, titanium and platinum can perfectly tolerate high temperatures. But seriously though, there is an option. We could settle underground, where the temperatures aren't so frenzied. If we lived underground, we might evolve with large eyes to better capture light. We might also evolve thicker skin to protect ourselves from the intense radiation. Basically, we have two options: become metal or become moles. Let's move on to Venus. This planet is extremely hostile. First of all, Venus is known for its thick, more toxic than your ex type of atmosphere. The whole planet is covered with carbon dioxide, and its surface is absolutely dry, making it incredibly hot. The average temperature is around 847 degrees Fahrenheit, making it one of the hottest planets in our solar system. Also, don't forget about the crazy pressure. Standing on Venus would be like standing 3,000 feet underwater. Only particular hardy microbes from Earth could survive in such conditions. So, if you want to live on Venus, you might have to become a microbe. But unfortunately, since we're not microbes, we have to wear special gear and equipment to survive there. Maybe we'd have to develop a heat-resistant exoskeleton to protect ourselves, as well as get some new lungs that can filter out the toxic elements in the atmosphere. Let's talk about our favorite red sibling, Mars. The first noticeable change after a few hundred years would be your new skeleton. The gravity on Mars is much weaker than on Earth, so your muscles and bones would shrink. To make up for this difference, you'd have to eat more and probably start going to the gym. Also, you'd have to adapt to the low atmospheric pressure and colder temperatures. You need to retain heat, right? That means you'd need a thicker layer of body fat. Sorry folks, but on Mars, we might become fatter. Another reason to start working out. Another big change would occur in your skin. Your skin is like a big barrier that protects you from harmful things such as bacteria, UV light, looking totally creepy, and so on. So what would happen to it? Most likely, you would turn orange, due to the carotenoids. Carotenoids are a type of nutrient that you get from foods such as carrots, potatoes, tomatoes, and so on. They protect very well against ultraviolet radiation on Mars. They only have one downside. By eating a lot of pumpkins from the Martian farmer's market, you'll gradually start to turn orange. But maybe it's not so bad. Maybe life on Jupiter would be easier. Yeah, no, it has no solid land. This planet is made up of hydrogen and helium and is referred to as a gas giant. You would simply float there, like in a huge cloud. And even if you managed to land and try to walk, it would be like moving through a super thick fog. So how would we evolve there? Firstly, we might become much larger in size to withstand the immense pressures. Secondly, the temperature fluctuations on Jupiter are enormous. The surface is terrifyingly cold and the temperature rises significantly under the outer layers of the atmosphere. Thirdly, if you lived on Jupiter, there would be no verbal language. This gas giant absorbs radio waves, so even if you were speaking, no one would hear you. There would be no music either, so no parties. And what's the point then? Hey, maybe we could communicate with sign language, but that's not so simple either. Jupiter is full of wild winds and storm clouds, so it's unlikely you would be able to see anything. So even if we evolved there in some way, our lives would still not be easy. Before landing on Saturn, you would probably want to check out its iconic rings, but you wouldn't be able to do that because Saturn's rings consist of a bunch of ice particles flying in space, so it would be extremely hard to land. So let's go straight to Saturn itself. At first, it may seem that Saturn is not bad for us. Some layers of this gas giant have quite pleasant temperatures. If we dive deeper into Saturn, it gets surprisingly warm, up to 26 degrees Fahrenheit in its second layer. This is an average temperature in countries like Sweden and Canada. But unfortunately, this is only one such layer. The rest of the planet is incredibly cold, so in order to survive on Saturn, we'd have to do a lot of work. In addition to the cold, we'd have to deal with the planet's harsh environment, including its intense storms, strong winds, and radiation. To protect ourselves from these conditions, we'd need to evolve tough skin, again, find some insulation, and so on. Next planet is Uranus. Uranus has a very different environment from Earth, with much colder temperatures, a lack of a solid surface, and a much different atmosphere. It's like another Jupiter, but with blue vibes. It's not that bad though. There's even water on Uranus. The only problem is, the planet is full of ammonia, that nasty stuff we use for cleaning, so don't be surprised if you feel the gross smell. Also, it's incredibly cold out there, almost like a never-ending winter. So what would it be like to survive in such a dark and harsh environment? We'd need thicker skin, again, to cope with extreme temperatures. And again, we'd need larger eyes to see better in all this darkness. We might even have to develop a new hearing system, like that of dolphins. Wouldn't that be fun? Let's move on to Neptune. If human beings were to evolve on Neptune, they would need to adapt to its harsh conditions. Neptune, the 8th and farthest planet from our Sun, is another gas giant. The only difference is this planet may have a solid core. If we were to live on Neptune, we'd need to float or swim in its methane-rich atmosphere. We'd also need to develop gills or something like that in order to breathe. Basically, we'd turn into space reptiles or cosmic fishes. The gravity on Neptune is slightly stronger than Earth's, but strong winds make it difficult to stand in one place. To withstand the wind, we'd need to be much heavier. Once again, you need to eat a lot and pump up some muscles. Yeah, technically it's not a planet, but we still love it and can't forget it. A small, distant, and incredibly cold world. Pluto's even smaller than our moon, and because of that, there's almost no gravity there. It will be extremely difficult to stand on it. To avoid accidentally flying into outer space while playing football, we need to create a fake gravity machine. And if we don't want to feel dizzy, we need to evolve a brand new nervous system. But Pluto isn't all that bad. For example, there's liquid water under the surface, and even some icy mountains. Maybe it would be possible to survive there if we had some serious equipment, clothes, supplies, and… nah, too much hassle. Anyway, From the scorching heat of Mercury to the freezing temperatures of Neptune, each planet has a unique set of environmental challenges and opportunities for evolution. While we may never truly know what humans would look like on these other worlds, it's exciting to consider the endless possibilities. Never stop looking at the stars and asking these questions.